Alright, hello everybody. In this video, what we're going to attempt to do is to write a markdown file that will then be converted into the 3 files required by PrairieLearn. We're not going to start from scratch. Instead, we're going to work from a template. And so the first thing I'm going to do is I'm going to log into GitHub. And I'm going to go to the Open Resources repository, and let's go back to the instructor physics bank, and inside here there's a templates folder. And so we'll look inside, and there's a bunch of templates that have been created for us. One of them is number input, and the problem that we worked on last time, I think it was chapter 12, problem 55 from volume 2 of the OpenStax book. That was one where that would require a number input, a numerical input. So let's go ahead and look in there. There's a MD file, and we'll take a look at it. And I'm just going to go ahead and copy everything that's in there. And I've got Notepad++ open, and I will paste the stuff into Notepad++. And let's save this as, let's see, I'll put a new folder here, MD file, and I'm going to call it something like OpenStax University Physics, Volume 2, Problem 1255.md. And when I put the .md extension, Notepad++ does some nice formatting for me. Okay, and so we'll just go through this. The file structure is already created for us. We just have to enter the right content. And so for the title, I might put OpenStax University Physics Volume 2, Problem 1255. And so if you're working on problems from the OpenStax University Physics book, I'll ask you to use the same kind of formatting for the title. The topic, so this was the magnetic force on an electron inside a solenoid, and so that's what I'll put as the topic. Okay, and then author, I'll put my name. I didn't author the question, but I'm going to be the one working on this markdown file. For the source, we'll put OpenStax University Physics Volume 2, Problem 1255. The version of the template, we can just leave that the same. The attribution is going to be some text displayed below the question that will let people know that the question was originally from the OpenStax University physics book. And so we'll see that after the question is created. For outcomes, I'm going to leave that as undefined for now. We'll get rid of this. The difficulty we'll leave alone. Randomization we'll leave alone. We'll leave this alone. Tags. I'll show you where the tags are going to show up after we've converted the question, but I'm going to put stuff like OpenStax University Physics, and then we can add a bunch more. So we can let people know this is from Volume 2 of the book, and that this question was from Chapter 12. Oh. And that in Chapter 12 it was Problem 55. The problem involved magnetic force. The magnetic field was produced by a solenoid. The electron inside the solenoid is undergoing centripetal acceleration. And along with that, the electron was undergoing circular motion. And so we could just put a bunch of details about the question this will allow users to kind of search through what the question is about. So if they want to assign homework problems for questions that are about magnetic force, they might be able to search through the tags and find all of them that involve magnetic force of some kind. Assets we're going to leave alone for now. Hopefully in a future video, we'll have an example of a problem that requires some figures to be displayed, and that's when we'll make use of this assets. So a lot of the structure of this template file we're going to leave the same. So server and the indented imports will leave the same. So this is importing modules for the Python code that are going to be required. We'll leave all these as they are. However, note that NumPy is not there, so let's add import NumPy as NP. Okay, and then we start the question code, start the problem code. We'll leave this line alone, and so this define names, items, objects, we're not going to need for our problem, so we'll get rid of that. Define phrases and units, we're not going to need that either, so we'll get rid of that. Okay, so this is where we're going to define our variables. And so in the previous video, we talked about randomizing the number of turns per unit length for the solenoid. And so let's go back and let's use what we used previously. We used random choice, and then we used this NP linspace, and what we had is from 10 to 35 turns per centimeter, and we had 6 choices. So it could be 10, 15, 20, 25, 30, 35 is 6 different choices. And maybe we could just leave ourselves a little comment that the units of this variable is inverse centimeters. The other thing we had was a radius for the electron orbit, and we also used linspace for that. So we went from 1 to 3 centimeters with 21 possible choices. And so that's like 1, 1.1, 1.2, all the way up to 2.8, 2.9, and 3.0. And that is in centimeters. Okay, I'm actually going to copy this because another one of our variables was the speed of the electron. And so it had a coefficient that last time we varied, again from 1 to 3 with 21 choices. I'll not use the units right now because that's just, V just represents a coefficient. We're going to have that V is going to be a coefficient times 10 to some power, and we'll have a random choice for the power from 4, 5, or 6. Okay, well, hopefully that worked. The next thing we're going to do is we're going to store the names of these variables so that in the question file, the params.n will be equal to whatever n was chosen by this random choice. Likewise, we'll have a radius, and I'll copy this. We'll have the coefficient of the speed. And we will have the power of 10 for the speed. Okay, so what we have to do next is we have to fix some of the units in our number so that when we do the calculation, it'll come out in a sensible set of units. So first, let's see, we can convert n from inverse centimeters to inverse meters. And so we're going to multiply by 100 centimeters over a meter. So we get times 100, and then we can let ourselves know that we've converted the units to inverse meters. The radius is in centimeters, and so we'll divide by 100 to convert that to meters. And the velocity is going to be the coefficient times 10 raised to whatever the power is. And after we've done that, we'll have our velocity in units of meters per second. Okay, if you remember, our question also had some constants that will be required. One of them was mu naught, the permeability of free space. And so we can define some constants. So let's say mu naught is equal to 4 times 10 to the minus 7 times pi, and we'll use numpy for pi. I'm not going to put in the units because I don't remember what they are and I don't want to work them out right now. We'll also need the mass of the electron. It was 9.11 times 10 to the minus 31 in kilograms. And the charge of the electron, or the absolute value of the electron charge, is 1.6 times 10 to the minus 19 coulombs. Okay, so what we can do then is we can calculate the correct answer. Oops. Notepad's trying to autofill me and doesn't always get it right. So if you remember, what we were asked to calculate was the current, so we'll use I for the current, and it was mass times velocity divided by, let's see, mu naught times the number of turns per unit length times Q times R. And because we've already converted units into sensible things, we'll get a current in amps. Okay, so now we need to pass the correct answer into the question file that's going to be generated, and we'll just say that the correct answer is going to be equal to I. And that's it. So this part is going to be populating what is going to be called server.py, and it's one of the PrairieLearn files that's required. So we'll leave this part the same, and then there's some prepare, parse, grade sections that we're not going to touch, but we will come back to in a future video, I hope. And so, okay, for now, let's just try to get this basic question working. All right, and so part one. So the type of question, we're doing a number input, so we'll leave that the same. And then these PL customizations are options that PrairieLearn has for number input questions. So weight equals 1. Because we're only asking a single question in this problem, doesn't matter what we put the weight, so we can leave that there the same. Allow blank means that a student could submit a blank answer, and I think that would be graded as if it was entering a 0. Let's not allow that. Let's say if a student enters a blank answer, we want PrairieLearn to say that's invalid, you have to enter a number. Okay, label. In the little answer box that's going to be created, it's going to say something equals, and then that's where the students are going to type their number. So we want that to look like a current. So I is equal to some kind of number they're going to enter, and then it's going to be followed by a suffix. And so we would like that suffix to be the units of the number. And so we'll use some LaTeX notation and get that to be amps. And then comparison, what we could do is we could require that students get this exactly right to a certain number of sig figs. In my opinion, that causes some challenges because if they do rounding in previous steps of the calculation, they could get an answer that's very close but be incorrect at one of the sig fig digits. So I like to use relabs. What this stands for is relative and absolute tolerances. And if you use that, then you can go ahead and specify the relative tolerance. And I typically use 3%. And I don't find the absolute tolerance to be very useful. And so I'm going to say that that's going to be 0. Now hopefully that's all we need for those customizations. And the next thing we'll edit is the question text. And so I'm going to, what's this part? I'm going to get rid of this part, and then we'll write some new question text. So I showed you the question in a previous video. It says that a solenoid with, well, in fact, maybe I can even find that question text. Let's see if I can find that quickly. I know what I could do. Let's open this. OpenStax Volume 2. Bring it over here. And we'll try to find Chapter 12. Okay, so we're getting close here. There's Chapter 11 questions. Here's Chapter 12. All right. So here's our question, 55, right there. So there's our question. Let me get Notepad here and see if I can get both of these on the screen. Right. A solenoid with 25 turns. And so we're going to have our 25 turns be a variable. So the notation is params n. And I'm going to put that in between dollar signs so that it gets formatted like a usual number. And so we'll say turns per centimeter carries a current and I formatted in LaTeX notation. And then we say an electron moves within the solenoid in a circle that has a radius of 2 centimeters as in perpendicular. So I don't particularly like how they've written this, so I can take some liberties and reword it a little bit. So I'm going to say an electron moves within a solenoid in a circle of radius, and then there's going to be another variable. And in fact, what we'll do is we'll have some units in here, centimeters. And okay, good. So let's put a period here, and then I'm going to say the circular, let's say the plane of the circular motion is perpendicular to the axis of the solenoid. Okay, good. All right. So we can say, again, I don't quite like if the speed of the electron is something, what is I? So I'm just going to say the speed of the electron is... Okay, and so we did something a bit different here where we said our velocity was going to have coefficient v. So I'm going to write params.v, and then I'm going to continue with some latex notation. I'm going to put times 10 to the power of, and then we had params.p, and then that is going to be in units of meters per second. And so finally we can say, what is the current I in the solenoid? Okay, good. And so all of this other stuff, I think we don't need to change right now. Like I said, I hope that we'll come back and fix some of this up in a future video. Okay, so let's save that. And what I'm going to try to do is I'm going to try to convert this now into PrairieLearn files. And, you know, there might be an error. We'll find out in a second. What you would do, and again, this will be shown in a separate video, and Faraz has already talked about this, is you will upload this to GitHub, and in the background, there's going to be some file conversion done for you. But I just want to see what happens here. And so I'm going to try and convert this using some Python code here. So I just have to get the path to the question correct. And so it was dmd file, and then it's OpenStax University Physics Volume 2, problem 1255. Okay, let's see if that works. Okay, so now if I go to that directory, md file, oh, here's the files that have been made. So I'm going to copy these guys, and what I'm going to do is I'm going to try and look at these in PrairieLearn. So I've got PrairieLearn running. And let's see if we can find this file. Okay, so there it is. A solenoid with 15 turns per centimeter carries a current I. An electron moves within the solenoid in a circle of radius 2.5 centimeters. The plane of the circular motion is perpendicular to the axis of solenoids. The speed of the electron is this. What is the current in the solenoid? And so I'm just going to enter a random number here and grade. And okay, so what we see is that here the correct answer is given, but there's a bunch of extra text here that we don't want. And so let's go fix that before we forget. And so here it is. So it's this extra text. Everything here will get inserted directly into the question panel. So let's get rid of that. And was there anything else that we wanted to think about? I think here we'll get correct insert it into the answer panel. So let's get rid of that answer panel stuff. Here's answer panel. So get rid of that. Now I didn't see this please enter a numeric value, but I think we can probably get rid of that as well. Okay, so let's save this, and I'm going to rerun this conversion, and we'll get a new set of files here. And so these files at 127 were updated. So these are the new ones. I'm going to copy those, replace these guys, and go back to PrairieLearn. And find that question. There it is. Okay, good. And so now we see there's something unpleasant about this. The random choice, when it picked a coefficient for the electron, it picked 2.4, but then a bunch of zeros with a 4 at the end. And so sometimes it does that, and sometimes it doesn't. So now the radius has an extra bunch of zeros followed by a 4. And so often it doesn't do that, but sometimes it does. And so we would like to correct that. But anyways, let's put in a number. That's wrong. And another thing that is unpleasant about this is that the correct answer is given with a huge amount of sig figs. And so it would be nice to change that. But let's just, for the sake of completeness here, put in a correct answer, and then it gets graded correctly. So that's good. Notice that if I put in a negative sign, it just gets graded wrong, and there's no feedback given. So one thing we will probably try to do in the next video is to see if we can implement some feedback where it does some simple error checking, like looking for sign errors and looking for errors in the power. Like maybe when I did my calculation, I calculated an answer in milliamps and I forgot to convert to amps, so I would have entered 1.55. And if I did that, it would just be marked wrong, although I'm only off by a factor of 1,000 from a unit error. So we could implement some error checking of that kind as well. So for now, we can put in the correct answer. And there we go. Okay, so let's see if we can fix the problem with these extra zeros. And so we'll go back to our markdown question. And what we're going to do is we're going to add some formatting to some of the quantities. And I'm actually going to do it right here. So n. What we're going to do is we're going to use this notation that I think looks something like this, dot format. Let me type it in and then we'll talk about what all this stuff means. So, I mean, I don't know why the syntax is the way it is, but I've copied it down. This F means that we want to enter our number as a float, and we want to have 0 digits after the decimal place. And so this is for the number of turns per unit length, and so that's going to be either 10, 15, 20, 25, 30, or 35. So we just have an integer number. And then we could do the same thing for the radius r, but in this case, maybe we do want to have a couple of digits after the decimal place. We certainly want to have at least one because our random choice is going to select between from 1 to 3 in steps of 0.1. Same thing for the velocity, so we want to have 2 decimal places. And then for the power, that's going to be an integer, and so we'll have 0 decimal places. So let's just save this. Let's reconvert our markdown file to the PrairieLearn files. We'll find those PrairieLearn files and move them into the right place. Let's update the question in this PrairieLearn. And now, every time I make a new variant, I'll never get in the question like a whole bunch of unnecessary decimal places. Okay, and like we asked for, the 35 doesn't have any digits after the decimal, and then we have 2 digits after the radius and the coefficient of the velocity. Okay, so now when we enter an answer, we get, okay, we still have a whole bunch of extra digits in the correct answer. I also don't like that this attribution is in the correct answer and submitted answer panel. Maybe we can ask Faraz about that. So what we're going to do is we're going to go and see if we can do the same sort of trick over here for our correct answer. And let's try it out. So we want a current with maybe well, let's try 4 digits after the decimal. Okay, so we'll save that. And we'll regenerate the PrairieLearn files. We'll find those files, copy them into the PrairieLearn course. And so I'm running PrairieLearn locally on my machine, so you won't be doing this, but I just do this for the purposes of showing you the question. Okay, and so this is what I thought. We're gonna get an error. And so when we do this formatting of the number that we're passing to the answer, it's complaining that what the formatting does is it converts that number into a string. And PrairieLearn's complaining that we've passed a string to the final answer. So it doesn't like that. And so we can't do that. And so we're stuck with the PrairieLearn version of this answer. And that's another thing that we'll try to fix in the next video. So if I undo that change, we should get back to what we had before. And so load questions. And we'll just, actually, so this, see when I entered nothing, when I left that blank, it said invalid, can't be graded. And so if I ask why, it says I need to put in some kind of valid input. And so it could be an integer, something in scientific notation, or a fraction or something like that. Okay, so we just put in a number 0.225. Well, here, I'll put something that's a little bit wrong. 224 is different than 226, but if I grade it, because it's within 3% of the correct answer, it's graded correctly. Okay, and so that's the basic numerical input type question. So I hope this was useful. I'm going to follow this up with a second video that describes how we can add in a couple of nice features. Okay, thank you.